Hi, and welcome to Question for the Day with David. On today's episode of Question for the Day, we have a question on the screen that says, how many grams of carbon dioxide, CO₂, are produced when 33 grams of propane, C₃H₈, burns completely in oxygen? Alright, so let's go ahead and solve this question step by step. First thing to note about this question is that it is a stoichiometrical question. Okay, it has to do with stoichiometry. And like many other stoichiometry questions, when you want to solve them, one of the basic things you need is a balanced chemical equation. So let's go ahead and write the balanced chemical equation for this chemical reaction. So they said how many grams of carbon dioxide are produced when 33 grams of propane burns completely in oxygen. So the reactants are propane, C₃H₈, and oxygen, O2. Now, one thing you must know is that propane is a fuel or fuel, whichever way you pronounce it, and oxygen is basically oxygen, a gas. And when fuel burns in gas, two things are produced: carbon dioxide and water. Carbon dioxide and water are produced. So let's go ahead and balance this chemical equation. So let's check out for the first element we have. We have carbon on the left and we have carbon on the right. How many atoms of carbon are here on the left? We have 3 atoms of carbon. On the right, you can see we have just 1 atom of carbon. So to make these 3 and this 1 to be equal, we just simply put a coefficient of 3 in front of CO2. That way, carbon has become balanced on both sides, 3 on the left and 3 on the right as well. Now that brings us to the next element, which is hydrogen. On the left hand side, you can see we have 8 atoms of hydrogen because of this subscript of 8 over here. And on the right, we have just 2 atoms of hydrogen because of this subscript of 2 over here. So 8 on the left and 2 on the right means we have to multiply these 2 by 4 to make them to be equal. So that means we need to put a coefficient of 4 in front of H2O to make hydrogen to become balanced. So now we've balanced carbon, we've balanced hydrogen. Let's balance oxygen. Oxygen is the last element on the left. We have just 2 atoms of oxygen because of these 2 over here. On the right, however, if you check, how many atoms of oxygen do we have? We have a subscript of 2 over here for this oxygen, and we have a coefficient of 3 over here. That gives us 3 multiplied by 2, which is equal to 6. And then over here, we still have oxygen. And oxygen has a coefficient of 4 over here. So we have 6 plus 4, which is equal to 10 atoms of oxygen on the right-hand side. And then how many atoms of oxygen do we have on the left? We have just 2. So 2 on the left and 10 on the right means we have to multiply these 2 by 5. So we put a 5 here to balance oxygen. So that way, our balanced chemical equation now becomes C₃H₈ plus 5O2, giving us 3CO2 plus 4H2O. So let's check if this chemical equation is balanced before we proceed to solve the rest of the equation. So we have the chemical equation to be C₃H₈ plus O2, giving us CO2 plus H2O. Remember, we put some coefficients. Over here we have 5, over here we have 3, and over here we have 4. So now let's check out for all elements. For carbon now, on the left hand side we have 3 atoms of carbon, and on the right hand side we also have 3 atoms of carbon because of this coefficient of 3 over here. So 3, 3 means carbon is balanced. For hydrogen, we have 8 atoms of hydrogen because of this coefficient of 8 over here. And then over here on the right hand side, we have a coefficient of 4, and then we have a subscript of 2. That means 4 times 2, which gives us 8. So hydrogen is also balanced, 8 on the left and 8 on the right. How about oxygen? For oxygen, we have a coefficient of 5 and a subscript of 2. That gives us 5 times 2, which is 10 on the left. And then for the right hand side, over here we have 3 multiplied by 2, which is 6. And over here we have 4. So which is 6 plus 4, that is 10. So we have 10, 10 for both the left and the right hand side. So the chemical equation is balanced. Now we can go into solving the equation. Let's do that very quickly. Now, from the question, we were asked how many grams of carbon dioxide. So the first thing they are telling us to focus on is carbon dioxide. Carbon dioxide is over here. How many grams of carbon dioxide are produced when 33 grams of propane? The next thing they are telling us to focus on is propane burns completely in oxygen. So now let's go ahead and get the mole ratios from the chemical equation before we solve to get our final answer. Now from the question or from this chemical equation over here, you can see that propane C₃H₈ burns to produce 3 moles of carbon dioxide. Over here we have just 1 mole of propane C₃H₈. And over here we have 3 moles of CO₂. How do I know it's 1 mole of propane? Because the coefficient over here is 1. And 1 multiplied by all of this remains the same. So from the equation, 1 mole of C₃H₈ or propane gives us 3 moles of CO₂. The question now says how many grams of carbon dioxide are produced when 33 grams of propane burns completely in oxygen. So therefore, 33 grams of C₃H₈ will now give X moles of CO₂, because the question says how many grams of carbon dioxide. Now let's do something very quickly. If you watch very well, all the units at the top here are given in moles, and the unit over here is given in grams. This one is also given in moles. So let's convert this to grams. We have 33 grams and we want to convert it into moles. How do we do that? Number of moles N is equal to mass divided by the molar mass. So let's convert it into number of moles and see what we have. So number of moles N is equal to mass. And what is the mass of propane? 33 grams. 33 divided by the molar mass. What is the molar mass of propane? We have C₃H₈. So let's find the molar mass of propane. C3 over here now becomes, what is the atomic mass of C or carbon? That is 12 times 3 plus hydrogen is 1 times, over here is 8. So altogether 12 times 3 gives us 36 plus 8. 36 plus 8 is 44 grams per mole of propane. So the number of moles now of propane will now be equal to 33 divided by 44. If we say 33 divided by 44, we have 0.75 moles of propane. So now we've converted this 33 grams into number of moles, 0.75 moles. So now from the chemical equation that we had, let's write out the chemical equation. Our chemical equation is C₃H₈ plus O2 giving us CO₂ plus H2O. Remember, we have 4 over here, we have 3 over here, and we have 5 over here. So now, from the chemical equation, we are focusing on propane and we're focusing on carbon dioxide. 1 mole of C₃H₈ produces 3 moles of CO₂. So from the question now, what will be produced when 33 grams of propane, and we've converted these 33 grams into number of moles. So 0.75 moles, because that is what we converted these 33 grams to become. 0.75 moles of C₃H₈ will now produce X moles of CO₂. So at this point, we can cross multiply. If we cross multiply, X times 1 will now be equal to 0.75 times 3. X times 1 is basically X, and 0.75 multiplied by 3. 0.75 multiplied by 3 gives us 2.25 moles of CO₂ produced. But now the question says how many grams? How many grams? So now we have calculated the number of moles of CO₂ produced to be equal to 2.25 moles. But the question says how many grams? So what are we going to do? We'll convert these moles into grams. As simple as that. So how do we convert from moles to grams? The formula that we used earlier on that says number of moles is equal to the mass divided by the molar mass. So in this case now we are looking for the mass. So if we make the mass the subject of the formula, this is over 1. We'll cross multiply. Mass therefore will be equal to number of moles times molar mass. So now let's impute our figures. The number of moles in this case is 2.25 times the molar mass now. Molar mass of what? Carbon dioxide, CO₂. What is the molar mass of carbon dioxide? Let's check it out. CO₂ will now be equal to, we have just one atom of carbon, which is 12, plus 2 atoms of oxygen, which is 16 times 2. This is equal to 12 plus 32. 12 plus 32 gives us 44 grams per mole. So therefore, mass now will be equal to number of moles, which is 2.25, times molar mass, which is 44 grams per mole. We do that math very quickly. We have 44 times 2.25. That is 99 grams. So altogether now, the answer to our question says how many grams of carbon dioxide are produced when 33 grams of propane burns completely in oxygen. We have 99 grams of CO₂. I hope you enjoyed every bit of what we did. For more answers to different questions for the day, I'd like you to subscribe, like this video, and follow for more. See you in the next video.